When electrons are confined into very small spaces, they can exhibit unusual electrical, optical, and magnetic behavior. From confining electrons in two-dimensional atomic sheet graphene to restricting electrons even further to achieve one-dimensionality, this broad line of research is transforming the landscape of fundamental research and technological advances in physics, chemistry, energy harvesting, information, and beyond. In a study published in the journal Nature Communications, an international team led by Aalto University researchers has now found that fibrous red phosphorus, when electrons are confined in its one-dimensional subunits, can show large optical responses. That is, the material shows strong photoluminescence under light irradiation. Red phosphorus, like graphene, belongs to a unique group of materials called one-dimensional van der Waals materials. A one-dimensional van der Waals material is a radically new type of material that was discovered only in 2017. Until now, research on one-dimensional van der Waals materials has focused on electrical properties. The team uncovered the optical properties of one-dimensional van der Waals fibrous red phosphorus through measurements like photoluminescence spectroscopy, where they shone laser light on the samples and measured the color and brightness of the light emitted back. The findings show the one-dimensional van der Waals material demonstrates giant anisotropic linear and non-linear optical responses. In other words, the optical responses strongly depend on the orientation of the fibrous phosphorus crystal as well as emission intensity, which relates to the number of photons emitted during a specific time. The researcher says that the way it responded in the experiments makes one-dimensional van der Waals fibrous red phosphorus a really exciting material. For example, it shows both giant anisotropic linear and non-linear responses as well as emission intensity, which is striking. The material's photoluminescence, the effect commonly seen in everyday life in reflective science or children's glow-in-the-dark toys when light is emitted after absorption, also struck the researchers by surprise. The team compared the photoluminescence of fibrous red phosphorus with monolayer molybdenum disulfide, which is well known for its strong photoluminescence, and found that the intensity of the photoluminescence was more than 40 times more intense, making it ultra bright, albeit very briefly. The researcher says that the strong photoluminescence of fibrous red phosphorus is unexpected. In fact, they initially expected that the photoluminescence of fibrous red phosphorus would be only weak. Based on theoretical calculations, this effect shouldn't actually be strong, so they are now doing more experiments to clarify the origin of its afterglow. The researchers believe that one-dimensional van der Waals materials like fibrous red phosphorus show real promise for displays and other applications.